Hello all, and welcome to the video on lesson 5.5 day 1 multiple angles and product to sum identities. So as usual, let's start off with a do first, kind of doing what we did last time, which was the sum and difference identities. So this problem tells us to find the exact value of the trigonometric expression using sum and difference identities. So here we're given cosine of 105. And what I'm going to go ahead and do is, again, as usual, let's give ourselves some space here. Let's go ahead and rewrite it over here. Cosine of 105 degrees. And if you recall from our lesson from yesterday, for the last video, what we want to do is we want to try and break down 105 into two numbers on the unit circle, special right triangles that we do know. So 105, if you think about that, is, let's try 60 plus 45. See, well that, we add that together, that's 105. So, oh, did the camera off in my excitement. That works. So what we're going to do is, let's go ahead and rewrite cosine of 105 as cosine of 60 plus 45. Now again, why would we want to do that? Well, because we know that we have a sum and difference identity if I have two things added inside of cosine. And again, cosine, if you recall, will always be cosine, let me write it like this, a plus b is always cosine a, cosine b. And if they're added, you actually want to do the opposite of what's inside here. So it's going to be minus sine A, sine B. Got a little messy there. Sorry, kind of got scrumpled up. But anyway, so this is going to be cosine of 60 times cosine of 45 minus sine of 60 times sine of 45. Okay, and once we've done that, we just look on our unit circle and see what cosine and sine are at that values. So cosine at 60 degrees on the unit circle is going to be 1/2. Cosine at 45 is going to be the square root of 2 over 2. Sine of 60 is going to be the square root of 3 over 2. And sine at 45 is going to be the square root of 2 over 2. That's nice. So anyway, we see we're going to have a common denominator. 2 times 2 times 2 gives us 4. The first term, square root of 2 times 1, is just the square root of 2. And minus the square root of 3 times the square root of 2, which is the square root of 6. And that is our answer. That was a nice, quick, easy one to start us off for today. Okay, so today we're going to talk about double and half angle identities. Well, we're actually not going to talk about half angle. There are those cases, but we're going to skip over them. We're just going to talk about double angle, stuff with 2 theta, basically. Double obviously means 2, so we're going to talk about what happens when sine or cosine has a 2 inside attached to the theta. So here we have some identities. Now, unfortunately, unlike the trig ones, or the sum and difference ones we learned about yesterday, these don't have a special pattern, so we just kind of have to know them. But you can actually prove them using the double angle, using the sum and difference identities, but that's an interesting proof if you want. So we're just going to use these today to solve these. So let's go ahead and look at number 1. So it says, let theta be an angle in the third quadrant such that sine of theta is equal to negative 7 over 25. Using double angle identities, determine the values for sine of 2 theta and cosine of 2 theta. Okay, so first of all, what I'd like to do is let's figure out what quadrant this is. So if we kind of draw gonna go ahead and draw a XY plane here. And the third quadrant, if you remember from algebra, this is the first quadrant. That's the second quadrant. And of course, this is our third quadrant. So it's going to be somewhere over here. That's where the angle is going to be. So what we want to do is say, okay, well, let's go ahead and actually draw a triangle in this quadrant that looks like this. And the angle theta that we're referring to, because it's in the third quadrant, that means it goes all the way around like this. That's our theta. But that's not as important for today's lesson, but just kind of wanted to make you aware of that. Okay, so let's remember back to our beginning lessons on sine and cosine. So remember that sine all the way back is actually opposite over the hypotenuse. So for sine, what we're going to do is say, okay, well, this is our angle right here that we're referencing. We say, okay, what is the side that's opposite to that? Well, that's over here, so that means that side is the top number in the sine, so that's actually going to be -7. And that makes some sense because it's going down, it's below the x-axis here. And our hypotenuse, the bottom number, is 25. Hypotenuses always have to be positive. Okay, so in order to do this, in order to figure out what the values for sine of 2 theta or cosine of 2 theta is, we're actually going to have to figure out what both sine and cosine are. Sine is easy because that was given to us in the problem. That's -7/25. However, now we got to figure out what cosine is. Well, recall that cosine is actually adjacent over hypotenuse. So in order to get that, remember this is a right triangle. We use our Greek friend Pythagoras' theorem. So Pythagoras' theorem says that if we take this side, two sides of a right triangle, and square them and add them, we should get the hypotenuse. Now notice we have the hypotenuse here, so we're actually going to have to say 25 squared is equal to -7 squared, and then we're looking for this side. We can maybe call that side x. We got to square that. Okay, so we do a little bit of arithmetic here. Square 25. Feel free to do that in your calculator. That's actually going to be 625. 7 squared, hopefully most of you know that is 49 plus x squared. We can then subtract 49 from both sides. That's going to give us 625 minus 49, which is 576. And that's going to be equal to x squared on the right side. To get rid of a square, we take the square root of both sides. X is going to be equal to the square root of 576, which looks scary, but that actually is a very friendly 24. So that tells us that this side over here is 24. But be very careful, because look where we are in the quadrants, right? We're on to the left of the y-axis. So this 24, this just gave us the length of that line of that side, but we actually want to put a negative in front of that 24 because it's to the left of the y-axis, so we know that that side has to be -24. Alright, so now what? Well, all we have to do now is use our what are we looking for? Well, we're looking for what sine of 2 theta. I'll write it over here and I'll kind of make a line to split this up. We want what sine of 2 theta is and what cosine of 2 theta is. And how do we get those? Well, we just use our double angle identities, which we just learned about. So we look up here and we notice there's only one for sine. So to get sine of 2 theta, you just take 2, put a 2 there, and multiply it by sine, which we just figured out, that's -7/25. And cosine times cosine, and cosine we figured out over here. Oh, we didn't write that out, did we? Cosine, we can do that really quickly actually. Cosine of theta is going to be, sorry, I'm kind of scrunching it in here today, but that's going to be the adjacent side, -24/25. So let's kind of box those off since I kind of made them a little too close. So anyway, in our angle identity, we put -24/25 there. And feel free to punch that into a calculator, all of that, because that's some pretty heavy math. But at the end, you will get a decimal if you do it in a calculator, so be sure that you do the math frac button, which turns into a fraction. And when you do that, That's going to get us 336, excuse me, over 625. And that is our answer because that is what sine of 2 theta is. And notice it is positive because the two negatives cancel out here. For cosine of 2 theta, we actually have three options, right? We have either, we could say cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. Well, let's just do let's do this one. Let's do the first one up here. And again, if you use any of them, that's not wrong. You'll get the exact same answer. So this first one says that if I square cosine, so if I square negative 24 over 25, and I subtract sine, which is negative 7 over 25, I should get cosine 2 theta. Again, enter your calculator, be sure you do math fraction, and that's going to poop out 527 over 625. And we have our answers, which 336 over 625, 527 over 625. Okay, let's move on to the next problem. So on the back, again, you'll notice I actually have I've hooked it up so that the microphone is on my mouth now. So if you hear me talking in your ear, that's exactly what I'm doing. Okay, so now we want to find if cosine is 3 over 5 on the interval 0 to pi over 2, find sine and cosine. Okay, so again, first things first, let's figure out what we're talking about here. So this time we're not given directly what the interval is, or we're not told the quadrant, we're just given the interval. So how do we find that? Well, we say 0. We know that that's pi over 2. So we've done 0 to pi over 2. Let's go ahead and do pi, and then 3 pi over 2. So basically, so what this is saying is that if it's in the interval 0 to pi over 2, well, that's nice because that's just over here. So we just have to worry about stuff in the first quadrant. Okay, so let's draw a triangle in that first quadrant. Okay, and this is our angle that we're discussing. Okay, so again, cosine is 3 over 5. Cosine is adjacent over hypotenuse. So the side that's adjacent to this is here. The side that is the hypotenuse is here. Now at this point, you might notice that this is a 3, 5 triangle, or a 3, 4, 5, so we don't have to mess around with that Pythagorean theorem business. If you still want to see, though, of course you can say 5 squared plus 3 squared, or sorry, equals to 3 squared plus some x, which would be this side, and you would do that and figure out that this was 4. Okay, so so that tells us that we know that sine now, which is opposite over adjacent, is 4 over 5. And cosine is given to us in the problem is 3 over 5. Alright, so what is sine of 2 theta? Okay, so sine of 2 theta, again, that's going to be 2 times sine times cosine. So we multiply those, 4 over 5, and cosine is 3 over 5. And this one, we could use our calculators, but we should be able to do this mentally in our heads. Notice we only have 5's in the denominator, so that's going to be over 25. Let's see, we could say 4 times 3, which is 12 times 2 is 24, or 2 times 4 is 8 times 3 is also 24. But anyway, either way, you get a 24 on the top. And then the second one, cosine. Let's use a different one we used, because again, we do have 3 options. The first time we used this one here, cosine squared minus sine squared. Let's use the second one. Let's go ahead and say, or actually the third one, 2 cosine squared minus 1. So again, you can use either 3 and they will work. So 2 times cosine, which is 3 over 5, minus squared minus 1. Let's practice doing some arithmetic here. So 2, remember you want to do the exponents first. Taking the exponent of a fraction, you have to do both the top and the bottom. 3 squared is 9, 5 squared is 25, minus 1. 2 times this fraction, again 2 you just multiply with it in the numerator. That's going to be 18 over 25 minus 1. And you could do this in your calculator, but if you think about it just a little bit, you should be able to get that that is negative 7 over 25. That's our answer. And this makes some sense, right? Because again, double angles, what you're essentially doing is you're doubling the angle, right? You're making the angle twice of what it is. So it's probably going to be somewhere, the angle 2 theta is going to be somewhere over here, and it makes sense because in that coordinate, we should expect for the sine in this quadrant to be positive and the cosine to be negative. So that makes some sense there, logically. Okay, so now that we've worked through 2, go ahead and try number 3 right down here on your own. It's not too bad, so give it a shot and pause the video and try it out. Okay, so now I'm assuming you've paused it and worked through 3. So let's go ahead and work through 3. So sine is 4 over 5, which you actually noticed was the same one over here. But again, we do have to pay attention to the interval. So let's write out our graph here. Again, the visual representation does help a lot. 0, pi over 2, pi, and 3 pi over 2. Okay, so what's going to happen? Okay, so we know that we're going to make our angle. Our angle is this one, but again, we want to reference the reference angle when we're talking about sine and cosine. Sine is, again, opposite over hypotenuse. That's going to be the opposite to the angle over and then the hypotenuse is up there. Again, another 3, 4, 5 triangle. Don't have to do Pythagorean theorem. That's why I've always said knowing your special right triangles is really important. So cosine is adjacent over hypotenuse, but be careful here because look at what's going on. It's to the left of the y-axis. So this is not just 3, is it? Hopefully you noticed that. This is actually negative 3. So when we make cosine, we're going to say negative 3 over 5. Sine, we're given in the problem, is 4 over 5. Okay, so then we just want to find sine of 2 theta and cosine of 2 theta. Sine of 2 theta, well, that's again going to be 2 times sine 4 over 5 times negative 3 over 5. We actually already did this, didn't we? We did this up here, kind of, except one of them is negative. So instead of saying 24 over 25, we're going to say negative 24 over 25. And cosine, again, you could have used any of the 3 double angle identities. For solidarity, let's go ahead and use the third one. We didn't use 1 minus 2 sine squared. So we're going to say 1 minus 2 times sine, so 4 over 5 squared. Again, you can do this in your head. It's not too bad. Do the exponent first. Square 4 is 16. Squaring 5 is 25. 2 times 16 is 32. And 1 minus 32 over 25 is going to be negative 7 over 25. So notice both sine of 2 theta and cosine of 2 theta are both negative, meaning that that double angle, which I'll write here, the double theta, is going to be probably somewhere in this area because both sine and cosine, or both the x and y coordinates, are negative. Okay, and that is it. Kind of a short lesson today. So again, be sure that you complete these notes, understand what's going on, and show them to me for your daily grade. Hope that was helpful. I'll see you guys again soon.